In today's video we're going to take a look at the MERG DTC2 2-channel block detector kit number 50. Now this kit uses what they call an open collector, or it can use 3.3 volts if we're using an ESP32 or a Pi Pico, or in my case, because I'm using an Arduino Nano which is 5 volts. So what we do is we supply the 5 volts which works the circuitry, and we supply a ground from the shield, and then the Arduino Nano GPIO pins will also supply the 5 volts. Now when a train is detected on the track, the channel will then send this down to ground. So what we've got over here, I'd like to also thank Chris Sharp, who created these graphics for the build guides. So thanks again for allowing me to use his graphics. So what we've got here is we've got the 2 inputs coming from the command station, and then we've got 2 outputs going to your track segments. The other thing to take into account, you need to potentially adjust the number of turns to suit your layout gauge. Now on my case, for a 00, 2 turns through the coil is working fantastic. If you're using N gauge, you might need to only have 1. So that's something you need to test out before you sort of go setting loads of these up on your layout. So I'm going to be using the Arduino Nano. So in the examples, obviously at the moment, the Nano, I haven't got an input only example. So what I'm going to use is the Arduino Mega. So I'm going to use this one here, which is the Mega 63 input CAN. Now I will need to change the sketch, and I'm going to show you that in the Arduino IDE. So we're going to start off in the user config, and the first change you'll possibly notice from the difference of the Arduino Mega version is I'm now using hex values for all of the node address. Now these first segments here are to do with my personal range, but this here is the actual node number that you have to change to suit your node. So here I'm giving it a value of OXOA, which will equate to node 10. So then when we come down to here, you'll notice we've got include GC serial.h. Now I use this when I'm testing the sketches to make sure I've done it correct. So I'm just going to use a USB lead to test the node within JMRI. To do this, we also then have to comment this piece here out. As we've done before, you've got the default factory setting, which needs to be 1 for the first time you run it, and then goes to 0 once you've uploaded it for the first time. Then when we go into here, obviously because it's an Arduino Nano, the MCP251 chip uses the CS pin on pin 10. Obviously I have changed some names. These will appear within JMRI, and obviously you've got your version numbers. The next thing we set is, you'll notice here we've got number of IO, and in this case I want 12. Now the other day I did mention I was only going to put 8. I've decided to go to 12 because it falls in nicely with the terminal blocks that I use. Then the next thing here is, you'll notice we've got 2 events for each input or each channel. Then the only other things I've changed really to the main sketch for the Mega is, you'll see here instead of it saying input, I've changed it so it reads blocks, and then I've just given it a rep name of BL. And then what that will do in JMRI, it will start off with block 1 up to block 12. You'll notice here these are the selections we've got. When we first start this up, it's going to be set as none. So we're going to be using it as an input with pull up. And then we've got these other values here, which we've seen before in the others. Then the only other things we needed to do really then is because it's an Arduino Nano, we've got to tell it what pins we're going to use. So in this case, I won't use pin 0 and pin 1 because they are RX and TX, and I don't like to use them if I can help it. But I'm going to use pins 3, 4, 5, 6, 7, 8, 9, and then A0 to A4. Then the only other thing I need to do is, because I'm going to have 12 IOs, I have to change this. Now in the Arduino Mega, you'll see this went through to, I think it was Reg IO 62, because obviously you count 0 as the first one. And then the only other things I do change is, obviously I like to put here what the version is. So I'm using an Arduino Nano R3 and it's called 12 blocks. The rest of the code we don't need to touch, and I don't really want to go into this because at this stage I think it might confuse you all a little bit too much. So here you can see I'm in JMRI. I'm using LCC using CAN via Grid Connect on COM port 5. So if we go into here, go to configure node, and then here you can see here's that node. So here's this AVR Nano R3 12 block. Then we can go into here and we click this here, and here you can see now it's loading the configuration. And then again, here you've got the node name, which is Nano R3 12 block. Then as I showed you before, what you've got here now, it puts in BL1 to BL12. Obviously you can give it a different description here if you wish, and then that will expand this here. Now the first thing I'm going to need to do is go into each one of these and then go input with pull up. I'm going to leave these to just purely on and off events. I don't want to use any delays or anything. So here you can see the event numbers for on and off. So if you notice here, the node on my case was OA, which is 10, but then we've got these 4 digits here. Now this allows you to have up to 65,000 events per node. Obviously we're not going to use that many. In fact, when you're looking in this one here, our maximum event number is 0017. So as before, we can use this to make a sensor, but what we need to do first is save it. So that's saved the node. Obviously, I've shown in the past, I normally like to have a blank node and make a backup first, so you've always got a blank one to restore back to. But as I said, and I have shown it previously, you can make a sensor. So we've now made the sensor. Then if we go into sensor tables, now you can see here we've got this node. Obviously we didn't give a name. Really you should give it a name, but you can see because I haven't actually got anything, it thinks it is active already. So the final thing I want to share with you tonight is, here you can see I've created a spreadsheet. Now this, in the past, I didn't keep documentation very well. So on this one, what I've done here now, I've created a block section, and then here we've got from blocks 1 to 12, and this is where the allocation is. So it's dock platform 1, it's going to be in JMRI BL1. So that is something I need to show in the next video maybe. And here you can see I know it's node 10, and then here's the on event and the off event. I'm also going to put block lengths in, but that's going to come later. Now I also here have got, does the block include a turnout? So in this one, yes it does, and the turnout involved is going to be T4, and then obviously this one here is the same, and here, but this peel approach actually uses 2 turnouts in that block, and it's turnout 1 and turnout 2. So hopefully, it is important to document your layouts as you're doing it, especially as we start going more into detail with LCC, because this one event could actually be used to trigger, animations and different things on the layout, or even slowing the train down. So anyway, I think this video has gone on long enough, so I'll say thanks again and see you again soon.